there we go.
Yeah, lovely, got it. So my name is Dan Jarvis, and this is Sam Edwards. We're both tech leads on the Capital One wallet app for Android. It's basically an app that lets you view your cards, you can lock and unlock them, see transactions, and the feature most people like is you get pushes every time you make a transaction, so you kind of know what your money's doing. A little brag about the app, we were the top rated finance app by a US bank in a recent survey based on App Store ratings. And we're the first US bank to have done a native contactless payment solution on Android. So that puts us up there with Samsung Pay, Apple Pay, Android Pay, and Capital One. So today we're going to do some fundamentals, just explain to everyone what continuous integration is, some productivity tips, just to help you get the most out of it. We're going to do a little case study of what we're doing on the Capital One wallet team. Going to discuss Jenkins as a platform, kind of ecosystem type discussion. And then at the end, some pro tips, in particular how to try and run your tests in parallel. So a quick show of hands, how many of you here already do some form of continuous integration? Okay, so that's fair. How many of you use Jenkins?
Nice.
Okay. How many of you don't use Jenkins but would like to? Oh dear. All right.
You got to test it for me first and show me.
Yeah, okay. Yeah. Maybe by the end we'll get some more hands up. So what is CI? It's basically a development practice that means whenever you change your code, you commit it back to the main repository, you run tests and builds automatically, check whether you broke something. Really important to detect problems early and to keep your whole team productive. Why should you do it? There's loads of reasons, I can get into loads, but this one is, in my mind, kind of the killer reason. If you do any kind of app development professionally, what you're going to find is over time you add more and more features to your app, and you can just not test it all manually. Like you start to test it all manually, you can do it, and over time, all those features interact with each other, the combinations get bigger, and it creates this thing called the testing gap, where over time you just cannot cover it all. In my mind, that's the reason why you need automated tests. And as soon as you have automated tests, you should have continuous integration. There's a bunch of other reasons as well. I listed some of here. Would love to talk about them more at the end if people want to, but I think if I was to pick one little headline from it, it would be that automation improves your productivity. So you can look at it, that the things you do every day, like script them, figure out what you're doing, put it in a script, have everyone be able to run that script, run it yourself in somewhere like Jenkins. What you're effectively doing is you're just cloning yourself into a whole load of mini-me's that will go out and do your work for you. And if you do that yourself, you get 5 of you, and if your team do it, you just have this big multiplier factor.
All right, so what is Jenkins? I went ahead and made this definition myself. So it is a server that executes jobs based on triggers. So these triggers can be a manual, I want to build this now. It can be, I want to build this every hour during the work week. I want it to be, when this thing happens, then trigger this to happen. But in essence, it's a job that executes based on a trigger. So these are basic terminologies that we see in Jenkins. You have jobs, plugins, and the master, slave, and executor. So I'm going to go through each one of those in a little bit of detail. First of all, a Jenkins job, once again, a Sam quote, it's essentially a script. So in Jenkins, you'd go ahead and set up a new job, which they call as an item in here. But you go ahead and click the new item on the left side. It would give you a little interface here and the web. You enter the name of your project or your job and then the type of job you'd want. After that, in this web interface, you go ahead and pick that I want to pull my code from my source repository. So I want to get it from CVS or Git or Subversion, and then how I want my build to be triggered. So by default, on every project, you can manually build it, but if you want it to happen based on time or based on other actions, then you need to go ahead and set that up. Lastly, on the right, you can add tons of build steps. This execute shell is like the easiest way, that you're just literally executing a script. So in this case, I'm just echoing the Android home just for sanity, so we know that that's the right path, and then running our build, which is part of our source code management. So at the end of the day, this is a Jenkins job. So we set it up, there's a name, here's a task it runs, and there's triggers. So one thing that's really nice about Jenkins job is this job should run a lot, and it should run in an automated fashion. So when it does, you want to know each time that it ran, how it did, and then what the output was. So on the left here, you have that build now button, which is your manual way of running the build. And the bottom left, we have 2 times that this job was actually executed, first and a second. And if we click into one of those, this is an example from our Android wallet integration test. And this is our 1,718th time this was run. So as you can tell, we didn't click it that many times. It's run in an automated fashion. And at the end of it, this one result of the test has our JUnit test report in here. So how is that done? Well, the JUnit test report is actually a plugin. And Jenkins uses plugins to enhance and add more features to what it is. So you have the ability when you manage your Jenkins instance to manage plugins. By default, you only have source code management options of CVS and Subversion. But if you add a Git plugin, which most of you would want to add, you can then pull down from a Git repository. The thing that we're primarily going to be talking about using is the Android Emulator plugin, which is fantastic. So all you do is you go grab it from the Jenkins plugin repository. On the right, during your configuration steps, you say, I want to run an Android emulator during this, and you say all your configuration options. In this case, I'm running a Marshmallow with a certain device, a certain ABI, so it's going to be an x86, 64, and some other configuration options. So in this case, it's going to make an Android emulator boot up so I can run all my tests and whatever else I want on it. Also, in the very fine print at the bottom, it says see also Android Lint plugin and the Google Play Upload plugin. Basically, plugins are just like apps, right? There's the App Store, there's different plugins. It like adds functionality onto what Jenkins is. Now, master, slave, and executors. So everything that you've seen so far is the master node. And the master node of Jenkins is responsible for all the configuration for all the jobs. So that's where you create your jobs, you manage them, you manage the plugins. But then all the work is not done on the master. It's done on slaves and on executors on the slaves. So a slave, for the example here, this is our black box tests that are espresso tests that are running. So in this case, we have one slave, the Mac2, and we have two executors on that, which means it can run two jobs in parallel on that slave. And so on the main master Jenkins instance, we can go ahead and view the progress of all this stuff, because that's kind of like the control center. And yeah, we can see that the one executor is being taken up by our 114th build of that. So what makes Jenkins so great? I think everything we've said so far is kind of should be convincing you already, but it's super easy to install. Usually it comes as just a pack like a Windows installer, or you can do it command line or whatever else you want. It's easy to set up. It'll auto set up your database for you if you don't want to do it in a custom way. It's open source, so it's on there. If you have a problem with it, probably somebody else has had that problem and fixed it. If not, you can patch it, or you can go ahead and fork it. There's actually over 3,000 forks in GitHub right now, so if you want to do something custom, somebody probably already has. Also, like I was saying, plugins are the apps for Jenkins. There's over 1,000 plugins out there that you can use. Jenkins is distributed and scalable, so like we were talking about the concept of slaves and executors. With the Jenkins master instance, you can actually have hundreds and hundreds of slaves, so if you're using cloud infrastructure, you could spin up a new slave and run more jobs. Also, it's been around for a really long time. It started out as a Hudson project in 2004, but it's become Jenkins. It's kind of been a name struggle back and forth, but it ended up being Jenkins. And lastly, it has, like, as plugins, there's enterprise integrations, and at Capital One, we use our typical Capital One username and password, but it allows us to log into Jenkins and be authenticated in that manner.
So what about some simple kind of productivity tips? This one seems really obvious, but I'm going to mention it here for completeness, because until you do it, you just might not realize how good it is. So using an instant messaging app like HipChat or Slack, anything like that, here you can see that the messages are coming back from a GitHub hook, so that Sam merged some code to master, and as a result it kicked off 5 different jobs in Jenkins. And just by using the HipChat plugin, it's pushing those back to HipChat. And it seems obvious, but why would you use this rather than email? Well, if I go on vacation for a week and I come back, I don't care that the build was broken for like 2 days. I mean, obviously it shouldn't be, but it's out-of-date information. Instant messaging is great for that kind of transient stuff that you don't really need long-lived information about. If you care about trends, there's a plugin for that, so you just don't need to use your emails as a way of tracking that. So Sam showed you a little snippet of this earlier. This is the standard kind of JUnit output for your test, and here we can see, oh, we had 6 failures. So, I mean, this is great. You can click on them individually, go in, and you can see the stat trace saying, oh, why did this particular test fail? But in a lot of cases, what you're going to want to do is go and look at the actual logs associated with that test failure. So by default, you would have to archive your log cat associated with this build. You would have to go back to the main workspace view, click spoon output folder, click to find the logcat, go into that, and now your logcat file is going to have 6 megabytes of trace for the hundreds of tests that you run. And that's actually really painful if you're trying to just look at one failure. Which leads me to what I just spoiled. Spoon is a great tool from Square that you can use. If you're doing Android instrumentation tests, you can use this. It's a really attractive HTML output for your tests. So here we can see different set of failures, 6 failures, and you can click on any of those and it brings you down to this more detailed view, but still with the summaries, a nice big headline for the assertion failure. And then the real piece of magic is these little notepad icons where what it does is it automatically partitions your logcat and just records the logcat for the test that ran here. So instead of having to go through tens of thousands of lines, you've just got a couple of hundred lines, and hopefully you've got your HTTP traffic in there as well, everything you need to diagnose the problem.
So while diagnosing a problem with a headless test is really easy using logs, if you have an espresso test that's running on a continuous integration server, you aren't watching it and seeing what's happening. So we've set it up using Spoon that has a Java jar file that you pull in. You can just go ahead and pass an activity and the name of the screenshot you want, and it'll take that. There's an espresso global error handler that we've hooked into where we can go ahead and take a screenshot upon a failure. And so in our Spoon report, it'll tell us the exception that happened, and here was a contrived example, but we were looking for a button with the text login, and it didn't find it because it's actually sign in. And so at this point in time, no screenshots were taken during the entire thing, but upon failure, we got a screenshot of this to give us some context and information so we can go and debug it, because otherwise we're digging through logs and trying to figure out how to reproduce this, let's run it locally. So it's a really nice window into our tests. And talking about window into our tests, you can also do this through your whole test. So this is kind of similar to what we talked about in the last talk here, but you can actually take screenshots for every action that you perform. So we use this thing called the robot pattern, which encapsulates different actions and assertions so that the screenshot is associated with each one. And I would not recommend, if you do screenshots, doing this on every build. Like, you're not going to be looking at them. You care to this test pass or fail. But we do this periodically on maybe a weekly basis, or if we have a release, we do it more frequently. And this way, product owners, designers, and developers can see this is exactly what our app looks like, and what's being tested in this test. So this is the login to home screen flow. We can see exactly what's happening there. There's no ambiguity. Everybody knows exactly what's being tested here. And that's been really important for communication, even just outside of developers. A little self-promotion. If you want to learn more about Spoon, Espresso, screenshots, the robot pattern, and everything like that, I'm talking here in a month at the Dev Fest DC, and the following week at DroidCon New York City about that.
So how do you actually run Spoon? Politely, you just read the manual. It's all really well documented. It's bundled in different ways, but the simplest way is you just grab the jar file with all the dependencies and just run it exactly like this, with the simple Java command. You pass in your APK and you pass in your instrument test APK. This other tip here just seems, again, really trivial, but I was using Spoon probably 2 years before someone pointed out I could do this. Normally when you get your HipChat hooks, it just has the open link, and you click that, it takes you to your normal Jenkins page, and then you have to go into the artifacts, Spoon output, index HTML, and it's just 2 more clicks, but over time you get infuriated doing it. But all you need to do is come in and just add this stuff to the end of your custom job completed notification. Another really obvious tip is you can click on these question marks to get advice on how to configure your plugins. And this little snippet of HTML is really, really helpful when you want to just jump straight to your Spoon test results. So another problem that you're going to find yourself need to solve is how do I run just an individual test or a set of tests? Unfortunately, the Android instrumentation runner provides some really nice arguments for you to solve these problems. So put this little table together. You can run an individual method or class by using these -e arguments. If you want to change code, you can also add annotations to your method or classes and use either standard annotations, like small, medium, and large. These have been around for a long time, and they were historically used. Like large tests would be your UI tests, small tests would be something a bit closer to a unit test, but still an instrumentation test here. And those are a standard that's been around a while. But it's also cool that if you want to get more than just those 3 categories, you can add custom annotations yourself. The slides should get advertised at some point after this is over, and there's links to Stack Overflow answers. Sam wrote one on how to use custom annotations. You have to just add a tiny bit of extra code because you have to define the annotation, but otherwise it's pretty easy to do. And then the final one there is you can set just one package of tests to run. And we use that quite a lot because we split our jobs into different kinds of tests and run some packages in separate jobs. And then just little for completeness, this is the documentation, what it looks like. If you browse for the Android instrumentation runner docs, I've already pulled them out for you into a table, but it's really useful when you find this. So we've been talking about Spoon and the instrumentation runner, like how do they play with each other? Well, the simplest way to think about it is when you invoke Spoon, just pass this --e parameter to Spoon, and Spoon will pass them all down to you, to the instrumentation runner. Nice and easy. There are some other ones further up. You can kind of tell that the E is at the end because this was actually added relatively recently. It wasn't around from the beginning. But you can use some Spoon ones. If you can't remember or can't be bothered to look up the instrumentation ones, you can use the size, class name, method name ones straight through Spoon.
All right, so everybody likes theoretical things and lots of documentation, but to actually see something that is really working and a real case study is always very solidifying and grounding. So we wanted to talk through what we currently have in Wallet for Android, and it's not everything we want it to be, but we think we have made really good steps, and hopefully it'll show you at least what can be done. So we've already seen the screenshot before. This is our pull request getting merged in and 5 different sets of tests being run. So I'm going to talk about why we have different sets of tests. First of all, we have black box. So, sorry, this is a testing pyramid. If you guys have seen this before, show of hands. So what it represents is at the very top should be the smallest amount of tests you write. At the bottom are the most tests that you write. So the tests at the top are the end user tests that take a lot of time. So it's like a user clicking on a button and doing things like that. And the tests at the bottom are the tests that are very programmatic and just testing one little part of your app that should run lightning speed. So you want the fastest ones to be the most and the smallest to be the slowest tests. So the black box tests in our case, and everybody has their own terminology, this is what we call them in our team, but a black box tests are Android Espresso tests that go out and hit our real servers. So these are UI tests that actually hit real servers. Then we have integration tests, which are headless Android tests, which means they run on the Android platform, but they don't actually have a UI at all. It loads up the app, it has multiple services that we use, and it validates that our server is behaving in a way that we think it should. So it's validating the server we have as well as our interactions with that server. We also have component tests. Component tests are also Android tests that we actually don't run UIs for, but they don't rely on external server at all. It's all mock data that's already provided in the app, but it tests that if we have 2 services in our app that actually work together the way they should. Finally, unit tests, as we talked about. These can be just simple Java JUnit tests that run with lightning speed and don't have anything to do with Android, or you can leverage something like RoboElectric to try to emulate the Android platform in a way that's headless.
Yeah, just one little clarification there. You sort of think like, oh, why are you writing UI tests at the top and at the component test layer? There's actually pretty identical code. The tests at the top are easier to write for the Espresso test, but the ones at the component level allow you to check that does the UI itself work even when I don't have servers to point at. And we have certain kinds of scenarios in our app, like maybe when we ask to email you a code to check that, verifying who you are. But those kinds of flows are actually pretty hard to do in a black box style because who's going to receive the email. So we do UI testing at both layers, and the component test layer, they're all done with mocked out dependencies.
Yeah, thanks, Dan. I didn't make that. But yeah, there was in the first session today about mocking APIs, we do have component tests that run on mock data that test UI, as well as error scenarios. Like if the server returns a 400, how does it react? We can't do that against a black box test with a real server. So the component tests, we have headless ones, as well as ones that do run UI tests. So all these tests are run on every pull request that is merged in. And there's a plugin that I'll talk about in just a second that allows this to happen. So we use GitHub Enterprise. I know some other people use other Git solutions or other source code repository things, but there's probably a Jenkins plugin that allows you to tie it into running your tests in Jenkins. So in this case, a pull request was made. So it's sitting there waiting to be reviewed by someone. And that went ahead and our Jenkins job got triggered by that pull request and now takes the branch of code that the pull request was made from and runs all of our tests on that. So at this point in time, this is our wallet case study. Not everything's perfect. We only run our unit tests, but we have 1,700 unit tests. So we feel pretty good when that runs. So after that's complete, you'll either get on the left, you'll get that it did not pass, or on the right that it did. And so as you can see on the left-hand corner, it says merge pull request, and that button is actually grayed out. On the right, it's green. You can actually do more configuration, so you can say, I don't want anybody to merge any code unless it passes. In ours, it's kind of a soft thing, so you can merge if you want to override that. This is all done through a plugin. As we said, like there's an app, there's a plugin for that. The GitHub Pull Request Builder plugin, which allows you on the right-hand side during your configuration options to set a build trigger, as we talked about, that would then go ahead and do this. So there's a little bit more configuration, but it's a build trigger. So I want to take everything we talked about and show our whole entire flow of what we do in our Capital One Wallet app now. So developer works on their stories, and they do a lot of Git commits locally. It's the first step up here. I don't know if there's a better way to point at it, but the next thing, they go ahead and make a pull request because their feature is completed. And so this is like, I finished the story, it now has this new feature. The pull request then triggers all the tests to be run with the Jenkins job, and that comes back with the results to GitHub and says, just like we showed on the last page, did it succeed or did it fail? And so you would not believe the amount of times we found bugs with that, because developers are inherently pretty lazy and cocky. So they're like, oh, it didn't break anything, but you didn't realize that Joe did something the other day which you actually broke. So this has caught a lot of bugs, and it has, definitely sped up a process. So anyway, once it's merged, then we have a trigger as well. So when there's a change in our GitHub repository on a certain branch, then it actually goes ahead and triggers a Jenkins job to assemble all of our APKs. So that's our APKs of a bunch of different flavors that we have, as well as our test APKs. And then those APKs are fed into 4 different types of tests. The unit tests, component, there's actually 2 types of that, as we said, integration tests and black box tests. And at the end of it, if everything passes, we feel pretty happy and confident about our app. Now, this by no means is like replacing the manual testing you'd have to do as well, but the goal is everything that we want to manually test, let's automate it. As you said, let's put as many mini-me's in there, and that's our mini-me's. So as we're talking about, Jenkins is really a platform, just like Android's a platform. There's apps that are built, there's plugins that are built. It lets you do a lot of things. And one of the main things that we like on Jenkins right now is a way to trigger jobs, right? It's doing it in a continuous manner, where when we merge a pull request, it goes ahead and runs our tests as we'd like. So if you were first to come on to Jenkins, you'd be like, okay, I want to run all my tests. This is great. I'm going to go ahead and compile just like I would, I'd do Gradle W, assemble my app, run the unit tests, run these tests. And at the end of it, it would all run in order. So you might look like this little lady in the corner, and you'd cry a little, because it would take a long time. But you're smart. You use Jenkins, right? You can make multiple jobs. So what you're going to do is have each type of test run in a different job. So that's great, 4 jobs. But there's still a few downsides to this. First of all, it's not great if you want to repeatedly rerun your tests. You're like, well, why would you want to rerun your tests? Well, if your tests are not deterministic, meaning it uses mock data, and everything is already within your app, the 2 types of tests on the right, integration tests and black box tests, rely on real servers. And those real servers we don't have control of. So we run those in a continuous manner to see if the servers are working as we expect. And because we're rerunning the same code, we don't need to recompile our tests. We just need to rerun them. So it kind of wastes extra time and money to have to rebuild those every time. So the way we got around that is we have one compile and build step, which happens. That's one job. And that job then goes ahead and triggers the 4 other test jobs that all run in parallel. So I kind of want to show how that works. So we talk about triggering more. What you can do is link between projects. And so in this case, under the configuration of the trigger, I've said when the test compile is finished, then I want to go ahead and trigger this build. So this is a configuration for one of the types of tests that we have, and it's established at dependency. So what it looks like in Jenkins is like this. So for the very top compile and build project, you'd look in Jenkins and it would say, these are my downstream projects. So that's our 4 types of tests. And then the upstream project would be the compile step. So it's that linkage that allows triggering to happen between things. And you might be wondering on this last slide, like, well, you compiled in one job, but then your another job's running your tests. How'd you get it there? And so there's the ability in Jenkins to copy an artifact, which is after the job was run, there's something that you want to save related to that job, or that execution of the job. And so in this case, what I'm saying is, when I run this test, I'm going to go ahead to the other project or job I have on Jenkins and copy all of the test APKs and the normal APKs over to my project before it runs. So they're already there for the last stable test compilation and APK compilation. So I'm just going to go ahead and move them over to my test, and it saves a lot of time that way. So continuous delivery. I always forget. I got it. No, No, this is me. Anyway, we practiced a bunch of times, but all right. Building a release candidate. So this is your typical flow in most organizations. You got your manager guy sitting up there with his legs up on the table. Yeah, we need to cut a build, guys. So anyway, the developer either runs it on his machine, or if you're super awesome, you make your build on Jenkins. And at the end of it, you get your APK, and this is our wallet APK. So then you say, hey, testers, let's go ahead and test all this. Developers, let's make sure it works well. So you go ahead and test it, and at the end of the day, you're like, okay, let's put it into our alpha store or somewhere so we can actually go ahead and test that. But what if I told you? Anyway, every build that passes your automated tests is a release candidate, right? So why do we have to take all that time to go through there, and why do we have to have the manager kick that off? This should be a process where when we check in code and it passes all of our tests, we feel confident that is a release candidate. So that's the whole goal, and if you listen to this, the talk at 1 p.m. with Adam Auerbach, he talked about just this continuous integration flow where if all your tests pass, you promote to the next level. And so we find that really valuable. In our case, whenever we merge a pull request to our master branch, then we compile, we run all of our tests, and we don't actually do this yet, but this is the vision, right? Is you would then upload to an alpha of Google Play, or there's beta by Crashlytics, and there's other app distribution like Hockey App, and other methods like that. So that's kind of the thing. And the Google Play, that's another, there's a plugin for that to let you upload to that. So there's a plugin for that. Cool.
So we talked a little bit about continuous delivery for clients there. What does it mean for other teams, like server teams? So, let's assume our server team are doing kind of good practices as well. They've got their Jenkins job set up. They're doing their pull request builders, and it's running their unit tests and their integration tests before they actually merge it. But what if we just go through? We're a client team. We've written all these tests that also include testing the server. They're in Jenkins. We know we can kick Jenkins jobs from other places. So what if I told you your automated client tests are now an API, right? So other people can use your client tests to validate their software. So in this case, you can actually expand it and have the server team kicking the client test to run against the server APIs. And some people would say, philosophically, that's wrong, right? I don't own the API, why am I testing it? And in my experience, the client tests have often found things that the server team haven't caught, and that's because they just have a different view of the services they provide. Like, they don't see that a client is going through these 5 sequences of things. So it's surprising how often you can catch things. And so another example of a subtlety here is a server team might forget that the version of your app that is 9 months old in production is using old APIs that no one is using internally anymore. So, if you're really smart, what you can do is have different jobs for your integration tests. One which is your newest app, and one which is your oldest production app. Still testing within your internal environments, but you're just ensuring that you don't accidentally destroy an API that your old client is using. And that has caught issues before. There is one slight subtlety to this, as some of you might have picked up on, which is how do you get your client tests to actually run against this kind of release candidate server, if you like. So let's just kind of walk through what that looks like for a server developer. So I'm sitting there doing my server development on my local machine, on my feature branch, testing locally. Everything seems to pass, so now I create my pull request. What you really need to do here is you need to spin up a transient server instance and then run all of your unit tests and integration tests against that transient server instance. So why are you doing that? What happens sometimes today is that code goes onto a shared test region and it hasn't gone through acceptance testing by all the clients yet, and sometimes things can break, right? So the idea is you're catching things like, the developer may have had some files that they forgot to check in that make the test pass on their local box. They may have environmental things that they have set up, but that won't survive through a clean install of that server. So doing this kind of process really catches things before you trample on other people. And then assuming those tests will pass, then what you can do is, after the merge, your server code just gets deployed to QA. So it's kind of formalizing this thing about how do you get your clients to sign off that you didn't break anything. Nowadays, we still frequently do things like email all the client teams to be like, hey, have we broken anything? After a couple of days, we're all good. And we're really trying to push more towards this, and more of our teams are building out those integration tests from the client side. And you can also just run your black box test too. Like if you just want to say my acceptance tests are what I need for sign off, we also do that. So a lot of benefits there. So pipeline views. I'll admit we don't know a lot about this ourselves. This is just a slide we pulled off the Jenkins website. It's kind of visualizing the flow that happens when you run one of your jobs. You're pulling stuff from source code management, you're loading dependencies, you're building things, you're running tests, you're deploying. Yeah, that's roughly what it's saying. So even the graphs we've shown you of how our jobs interact with each other, like they're a pipeline, right? We can all see this is some kind of pipeline. So there's 4 different Jenkins plugins for pipeline display. 2 new ones came out this year. The one that I'm showing here, the actual configuration of this view comes from a file that you keep in your source code management. So Jenkins will sort of build this for you based on you telling it the names of the jobs. So we're not using this one ourselves, but another team, Capital One, are, and I think it looks really cool, so we'll probably check that out at some point.
So that idea of having your Jenkins configurations in source code management is one that we've really liked and are starting to accept. So one thing we would suggest is not to keep that in your actual repository with your Android code. To keep this as a separate repository because it can be updated without having to actually change that version of your code. So what's nice about it too is it's going to be versioned, right? All the benefits that you get from using GitHub or from whatever else, you can actually see the changes of like, oh, I changed the script so I'm running it on this resolution now, or maybe I'm running it on your Android emulator or something. Like you can actually see what you've changed because in the past I've gone and updated Jenkins jobs and I'm like, wait, the last one worked. What was it? And no idea. So that's really great. It's also, so this is the example. If right now we run our spoon scripts in every single one of our builds, we used to have to go ahead and update if it was now 1.6 instead of 1.5 version of Spoon. Every single one we edit and then save and edit and save and edit and save. Where now we can, in our separate repository, we can just update the version number and it's good to go. But
we have 35 Jenkins jobs, just our team, just as a measure of how tedious that could be.
Yeah.
Sorry, you had a question?
Oh, sure.
Yeah. Actually, I've got a comment. So, like a newer instance of Jenkins, like Jenkins 2.x, has its own like built-in repo for storing all set functions, so you can store all your like reusable scripts as your own library inside Jenkins itself. Not like building another Git repository or something like this, but stored in Jenkins and then just store only the credentials that you need for specific project inside it, instead of keeping explicitly another repository only for build scripts.
Okay, and I think that is a good solution, but this last item might be another reason why you maybe not want to do that. And what if your Jenkins instance explodes, or you want to create a brand new one? If you're doing that, you're going to have to go in your Jenkins instance, copy everything, or in this case, all you'd have to do is have one job that pulls down all of your scripts from your source repository, and you're already set up and good to go. And now the subtle hack that I didn't mention yet is that when you execute a job, a Jenkins variable is the job name. So in this case, if all your build scripts are actually by name, so it's like mycomponenttest.sh, you could go ahead and name your Jenkins job mycomponenttest, and it would go ahead and execute that there. So this is the model we've taken that has made our Jenkins jobs much more maintainable. And if you want to add a new job in, you would just clone the job you had before, and the job name already updates. So you would just have to make sure that script is there and available.
So let's dip into some of the nuts and bolts about actually trying to run these things in parallel, because you may have noticed we've glossed over a little bit of it so far. This is a recap slide showing that we've got our compile step, and then we're outrunning all of our tests in our own jobs. That's great, awesome. But over time, say your black box tests, you're adding to them, they're starting to take longer and longer, and one of our agile tenets is we're trying to have our 15-minute build. So as your black box tests start to take like 30 minutes, you're going to start to look like a sad cat who really wants them to get faster. So
just a quick interjection. So the very first talk about mocking as well, they mentioned that their regression right now takes 8 hours. So this is something that can absolutely be applied. So
yeah, absolutely. So the obvious thing is like, how can I just split that individual test suite and run it across multiple devices and or Jenkins executors? So to visualize that, we've got our black box tests, and we just need some way of taking those tests and splitting them up, so a quarter of them run on each Jenkins executor. So the first time I was trying to get this to work, I came across this plugin called the multi-job plugin. So at the point when you come in and click new item, you've got this multi-job project. And when I first looked at it, I thought, oh wow, this is great. This is really going to do it. So this allows you to set up multiple phases within the job. And in this example here, you can see one of the phases passed, 2 failed, and so overall the job was shown as failed. This looked kind of interesting at the beginning, but there were a few problems. The first one was you're going to be using a whole executor while the top job is waiting for the other 3 phases to finish. I actually don't think you'll be able to solve that no matter what you do, but mentioning it for completeness. The second one was the sort of one I felt I could solve, and that was it was tricky to try and do the partitioning of the test suite. So what you could do naively is just take one of those instrumentation arguments, like splitting them into more packages, or separating them into different classes. And you don't want to do that. You want to be able to balance this stuff automatically. It's a real pain to do it manually. And then the last one, again, I think this is a kind of standard limitation. It's begging for an open source project to have someone help solve it. Someone should go do that, please. But when you get the results, it's not going to aggregate them all nicely back to the main job. So the kind of breakthrough for me was when someone pointed out that the instrumentation runner supports sharding. Great. Wow, I wish I'd known that earlier. So going into the docs is just a screenshot again. You can set the number of shards and then the shard index. So imagine you're running a script on 10 different machines. You just give each of them a different shard index. And what the instrumentation runner is doing is it's doing a stable sort of all of your tests and just taking every nth one based on the shard index. So at that point, great. Like I now know how to shard my tests. How do I do that with Jenkins? Like how do the pieces stick together? So there's this plugin called the Matrix plugin. Great name. It actually refers to multi-configuration everywhere that you actually use it. So you can kind of see Matrix and multi-configuration. I think they're pretty much the same thing. So you come in and having installed that plugin, you create a multi-configuration project. And it offers you this user-defined axis. And what you do in there is you give it a name of your choice, and you do a space-separated list of the values that you want to be feeding into your jobs. So what the Matrix plugin is going to do, in this case, it's going to spin up 6 separate build things that run on executors, and each of them would be instantiated with a different set of environment variables. In this case, the only thing that would be different is the node index would be 1, 2, 3, 4, 5, 6, depending on which one it is. And then how do you tell the job, when it's got that node index, how do you actually run the different shards? Pretty easy. You can just take this example from Spoon. This is also in their documentation. You're using the --e that we talked about earlier to pass the argument of Spoon's instrumentation runner. And we're passing in $node index to just pass the index to that particular job. So this doesn't solve 2 of the 3 problems we talked about earlier, but it does make it super easy to pass the sharding index to your build executors. The other real benefit of the Matrix plugin is it's going to be able to build you a whole set of parallel jobs for more than just one variable. You don't just have to define one of those axes, you can pick other things too. So what am I hinting at? The Android Emulator plugin that Sam showed you a screenshot of earlier, this can be used to take in arguments as well. So the screen on the right is a bit misleading, I'm afraid. The one on the right here is this is still the Matrix configuration section. It's nothing to do with the emulator. But what we're doing is instead of adding node index, we're adding 4 different variables here: density, OS, locale. These screenshots are all from the Android Emulator plugin documentation online, so you'll be able to see them in there. So we just defined some more variables that are going to have different values. When we actually come further down our build script and set up the emulator, what we're passing in is the values we just defined. So in this case, the Matrix plugin is going to spin up each of the jobs on an executor for all the combinations you just set. So it's going to do, one of them's going to get OS 1.6 with a German locale and whatever those horrendous display resolutions are. So this is a really old screenshot, I apologise, but nowadays you would probably be doing something like testing, I don't know, ice cream sandwich, KitKat, Marshmallow, N, and then perhaps three different largeness screen sizes. Taking Sam's example earlier of those screenshots for the whole app, like that would be awesome, right? Once a week, you can see what your app looks like on your three most extreme screen sizes and check that it still works on your three major OSs. So hopefully there was something there for everyone, something you maybe didn't know before. We have about a good solid 10-15 minutes left, so we'd love to take some questions. Let's try and start with the things that you think may be more beneficial to others, the more general questions, but then we would also love to...
Yeah, we'll probably take specific ones just out in the hallway just so everybody else can reconvene. But yeah, if you have general ones, please. Go ahead.
So when you guys are taking the screenshots, and you mentioned, you guys running it against like a device lab or something, or is that just with the emulator that's not running in headless?
Sure. So right now we're running it on a Mac Mini. It's run without headless. We're working on that for our AWS deployment so we can use like slaves upon demand. But at this point in time, we just have a few Mac Minis that it runs on. And we chose the Android emulator because you can have so many different configurations and it can just be on demand. So.
Do you want to do encore slide for that?
Yeah, sure. I've got a few encore slides. What about the Android emulator? What about the Jenkins? Or sorry, the Genymotion. That's new at Jenkins. So what about Genymotion? What about real devices? Okay, we'll just go into that. So the Android emulator, it's great because you can do multiple screen sizes and densities and everything else like that. You can also, so it's free. Anybody like free? It's also supported by Google, which is great. And it's super fast now. The ADB commands for installing an APK is actually 10 times faster than a typical USB device. Bad things though, we found out that the snapshot feature doesn't really work very well. So that's like kind of the pause feature or whatever, if you were to run the emulator and then just kind of pause it and then come back at another point in time. So the workaround that we do is because the overhead is so low, we recreate an Android virtual device every time we run our tests. And the time right now it takes is about 35, 40 seconds to create it and spin it all the way up to when our tests are running. So it's some overhead, but it works. Genymotion, we used that in the past before we went to the Android emulator because the Android emulator used to be something that you cried about because it was really slow, but they've done really great work this year in the Android tools team. So with Genymotion, it's great because once again, multiple screen sizes are easy. You just tell them what you want. It's super fast. So it runs on x86, so it can run natively on your desktop or whatever PC that you have. And the snapshot feature actually works pretty well. So the spin up time is not as much for Genymotion. Cons are it requires licenses, which can be really complex, especially if you want to do sharding and do all sorts of devices, all sorts of combinations and do it in parallel. Now, real devices. They're real devices. That's a pro, right? These are the real things that people are actually going to use. But what's bad is that you have to manage them yourselves, or you have to integrate with services like Google Test Cloud, TestDroid, Amazon Device Farm, which are really good things. So with those, you actually can test on a specific device what you want to do. Or if you have a problem with a Samsung S5, you can go out and do that. And I think those are very valuable, and even testing locally on a real device is very valuable. But for our continuous integration efforts, the Android emulator has had the most pros and the least cons for us.
Yeah, our QA team they're using TestDroid at the moment still, and with some real devices to get some additional real device coverage. Pretty much everyone I've heard of who's tried to manage these themselves, they get sick of it really quickly. The device is like, you have to manage, it's in the middle of an update, or like something went wrong, or it froze. I haven't used the new link. The LinkedIn team published, I think it's called Test Butler, which is a special thing that's designed to turn off a lot of the problems that stop your device being good for automating testing on it. So that may be something some of you might want to explore if you're really insistent on using devices. Yeah.
It's actually, earlier you kind of chuckled about it. So you want to be towards continuous deployment, and you said you're not there for Android Play Store as well as maybe internal testing. Is there any reason why you're not there?
So for internal testing, we are there. Builds are immediately available for testing internally, but it's more of a legal thing to be able to just push out something. So we need to have somebody on our team that's able to do that. So that's the reason.
It's a procedure thing?
Yeah,
it's a procedure team, yeah.
You can push to Google Play Alpha, and we probably could do that if we really want.
If we push for it, yeah, but.
I was just asking because, that was one of the key things we tackled earlier this year, and I was thinking it was more a procedural legal thing versus a tech thing for you guys.
Correct, yeah.
I think that the thing that might be holding back server teams, I don't think we're fully moved to AWS for all of the software that we deploy. That's going to make that kind of transient instance stuff a lot easier to do.
Cool.
So you mentioned you're running all this through Mac Minis. first question, are they in different locales, like not just in one place, or there are different time zones? And second question is, if they are, how do you manage going around like the firewalls for a corporation and having them be standalone instead of having been hooked up to a real personal device, so things like that?
Sure. So I think some of these might be Capital One specific questions, but yeah, sure. So we use the Mac Minis now because we have to. We don't want to use them at all. Like, we wanted to be on AWS, but like we're still part of that migration for Capital One. So we've had to, right now in Richmond, which is the location where I work, we have 2 Mac Minis set up, one next to me and then one downstairs in the DevOps team room. Forgot the rest of your question, but.
Well, if there are different locales, how do you access them to as a slave? Like, I'm sure they have to be in the somehow, right?
Yeah. So I mean, as long as they're set up to be slaves within Jenkins, so we have our own, like, master Jenkins instance. Each one's configured to be a slave. So when we set up our jobs, we say I want it to run on either this type of slave. So we can just say it's capable of running like tests on an Android emulator, or we can say on this exact one. So that's the way you would do it. Is you say I want my test to be run on this exact slave or this type of slave, and then it would just go execute on one of them, and you don't really care.
But in essence, the answer to your question is we should be using headless AWS-based slaves.
Yeah.
So Jenkins, one of the original authors, I forget how to say his name, he founded CloudBees, which do a cloud-based Jenkins, and I believe they've solved the problem of having slaves that spin up. I used that for a year, and it was great, a bit on the expensive side, but if you're just looking, how can I test this out myself without investing in setting all the hardware up, you can certainly do something like that. I should also say, for completeness, like, we're not trying to say all the other competitors are terrible. Like, I just am not super familiar with Circle CI, Travis, or Buddy Build, all these other ones.
Right.
So I'm not trying to make a statement that Jenkins is better than them. It works really well for us. Whoa.
Let's go yeah, go.
We heard like you have around 35 Jenkins jobs
Mhm.
in your project, right? So it's quite huge. So is it based on different platform or different code base or
Sure.
different timelines, or
So
what you have different flavors of the jobs?
Sure. So it's kind of similar to like the idea of the matrix job, where you have different variations, right? So we have different regions that we test against. We have a QA int, perf region, and so there's a permutation for each one of those. Then we also have our latest tests that run against our master code branch or develop code branch, and then we also have stable tests that run against that version of the app, and then we have our oldest tests. So you end up with all these permutations, and then we also split our jobs up by the type of tests they are. So the unit tests are one job, and then the component tests are one job, and the black box. So if you think of all those permutations, that's kind of why it ends up being a large amount. The matrix job might end up helping us in that case in some situations. So that might be something to think about.
That's exactly what I said. So we've got different flavors doing different environments and different branches. So the hit chat room here has a couple of little Easter eggs. So we hinted at this earlier, like, why would you want to rerun your tests even without recompiling them? We use them for monitoring. You get a lot of advantages when you're running like headless tests that go and test APIs. So if something fails, you can be doing a really detailed assertion, like this field was missing on this response. So gone are the days when the QA team come back to you and say, like, something's broken, you have to figure it out. Your tests are running every hour, and we have it outputting the results to these other rooms to tell us, like, this particular API is not behaving as it should right now.
And so,
One more
go ahead,
follow-up
yeah.
question
Mhm.
on that. So if you're running on the same code base, do you think that the logic which you want to build in, like run it once in a day or two times in a day or something, do you want to handle it on the code or on the code base or on the Jenkins?
Jenkins.
Yeah, Jenkins is all about the triggers. So when you want to run your job is all Jenkins, but what should be run is typically.
We go for hourly. So the default is runs every hour, and for a while we had it on a failure run twice 5 minutes after, just to make sure, like, oh, if this is transient, we can figure it out. But it's not quite stable enough right now to do that. But that's what I would recommend if our QA environment was more stable.
And one little tweak, so I said we haven't moved to AWS, but we actually have for all of our builds. The slaves that we have out there right now don't have a head component, so you can't actually see the UI, but we do all of our APK builds and our unit tests there. But the espresso tests run locally. Sorry.
Yeah, question?
Yeah, I was just curious what you guys use. You said for the component test, you're mocking data or stepping requests. What do you use for that? Do you use the mimic that there was a talk earlier on?
So we're not using that right now. In the past, we've used Retrofit. So it has a way. Retrofit is just an interface, and it allows you to describe what your REST APIs are. There's a way to basically create a mock instance of that using dependency injection. And so that's what we've had typically in our app, and we're moving right now to another library called WireMock. And it allows you to do the same thing. So basically, we programmatically create the model that we want it to be returned using like a builder pattern, and then we serialize that to JSON, send it out to WireMock, which ends up being very similar to Mimic, and then that will return back exactly what we want. So we basically program the exact model that we want, and then it's sent over the serialization with JSON.
I think there might be a talk coming up that you might find useful.
Well, yeah, I do have a WireMock talk in the future if anybody wants to talk to me. Yeah. Yep.
So how do you guys handle different type of sensitive data, like, I don't know, credentials, API keys, like in terms of Android key stores, if we are speaking about iOS, there are provisioning profiles and so on. How do you handle them using Jenkins?
So we use the standard approach, which is release builds there's only one server somewhere that knows how to sign our release builds, right? Like our actual production keys are on a very carefully protected server. If you see what the Square people do, they do something similar to that.
Yeah, our build script actually refers to an environment variable that's on that system. So on that system, it knows that this is the path of the actual file and the password that I need. And so it's only available on that one machine for release builds.
And for the client side, I think you're sort of saying like, we don't really do anything on the client side that has a secret in it, if you like. Like most good security is open, right? It's like we agree that there's a handshake. You shouldn't be able to look at a client and find something insecure that you shouldn't be allowed to touch.
Okay. So like, I'm getting it right. So that all like credentials and so on are stored on master of Jenkins. Yeah.
The only credentials we would have is our code signing certificate. So for our apps talk to a server, and it's the user's login credentials that let them in, and the servers are the ones that have security between them and the other APIs.
Yeah, and our DevOps team has a way that they're setting up for you. If you have secure information, they actually have it stored in an encrypted manner, and if they want to use that for another job, they would then be able to deploy it on the machine like we're saying, so that certificate's now available to be used like as an environment variable.
So we're going to wrap up now because we need to leave 5 minutes for the next person to set up. We'll hang around outside if anyone wants to grab us. Thanks very much for coming. We hope you found it useful.